Greetings, chemistry students. This is part 2 of your introduction to the infographic on the website, Understanding Global Change. So in part 1, you were introduced to the processes that are essential to how the Earth system works. To understand global change, we will turn our attention to the non-human a little bit, but more so in this part, the human phenomena that influence the Earth system, and explore what we can measure to determine how fast, or to determine the rate, and to determine how much, or to determine the magnitude at which the Earth is changing. First, I'm just going to kind of skip through some of the non-human causes of change, and I do want to let you know that you will be creating another model just like you did in our previous assessment. Some of the non-human causes of change, such as variation in Earth's spin, tilt, and orbit, or changes in the distribution of continents and oceans, cause changes on timescales of tens of thousands to millions of years, and they do not explain the rapid global changes we are observing today. Events that cause rapid change, like meteorite impacts or major volcanic eruptions, are rare, but when they do happen, they can have catastrophic consequences throughout the Earth system. And we have a couple of different non-human causes of change. Something that we've talked about here is Earth's orbit around the sun. We're not going to touch on that in this portion of the PowerPoint. And then on this slide, we are taking a look at plate tectonics and how they have changed the distribution of land and water cover over our globe. And then there have also been some slight fluctuations in the amount of energy released by the sun for more than 40 years. And so if this is something that interests you, you can certainly research this on your own. But now what we're going to do is examine some of the human causes of change. The fancy word for that is the anthropogenic causes of change, which are necessary for understanding how the Earth system has changed over the last century. And so in this, we're going to be looking at the outer red ring of our infographic. Humans, especially over the last century, have dramatically changed the Earth system by extracting and using Earth's resources to power and sustain modern life. Fossil fuels have been our primary source of energy, which increases greenhouse gases, something you should know, in our atmosphere. Use of fossil fuels is the primary cause of climate change today. Resource extraction and the burning of fossil fuels also release pollutants and waste that contaminate the environment and are harmful to life. Sustaining modern life through our industrial and agricultural activities also requires large amounts of fresh water, which we extract from the ground and divert from rivers and streams. So if you take a look at the 4 photos that you have on the slide here, you can see that they are all corresponding to different icons from the infographic. Notice that they all have a red border around them because they're going to be found in the red ring of our infographic. Humans have dramatically reshaped the surface of the Earth. So on the previous slide, we were looking at how we have extracted resources, and here we're looking at how we have reshaped the surface. We have removed forest and plowed and paved more than half of Earth's land. Over the last century, these activities have been enabled by technologies we power with fossil fuels. So it's kind of a double whammy. We're burning fossil fuels and spewing carbon dioxide into the atmosphere while we're also changing Earth's surface. Unfortunately, many farming practices introduce pollutants to surrounding ecosystems and do not sustain soils for long-term use. And again, if you look at the pictures, You have icons that match up with them that are rimmed in red. As we recognize how we are changing the earth, we can also develop technology and solutions that sustain human life and ecosystems. So humans can change the surface of the earth for, with maybe a negative impact, but we can also decide to change the surface of the earth in order to produce a positive, a positive consequence. Our ability to innovate will hopefully allow humans to mitigate climate change and be resilient in a changing world. Restoring habitats such as coastal environments can benefit human populations by buffering cities from rising sea levels. Forests can absorb greenhouse gases through photosynthesis and provide a sustainable source of resources. Innovations in renewable energy, such as solar and wind power, can provide energy we need for modern life without contributing to global warming. But again, this is a choice. However, it is a message of hope. For most of human history, our population size was relatively stable, but with innovation and industrialization, energy, food, water, and medical care became more available and reliable. Global human population rapidly increased and continues to do so, dramatically impacting global climate and ecosystems. We will need technological and social innovation to help us support the world's populations as we adapt to and mitigate climate and environmental changes. And so on this slide, you can see how populations really didn't change for most of the time, all the way over here, but then you can see how it just skyrocketed up. And the authors here are attributing these changes to better health care, more food, more water, better living conditions. And again, here's your population growth that is going to affect global change. You have now been introduced to some of the major causes of global change. We will now explore parts of the Earth system that we can measure over time to determine how fast, rate, and how much, magnitude, the Earth system has changed. In the Understanding Global Change framework, measurable changes are placed in the middle of the diagram and shown in blue. Studying past global change is essential for understanding and making predictions about global change today, and will help us prepare for a sustainable future. There are an enormous number of aspects of the Earth system that can be measured. Here we will consider just some of the most significant changes that are occurring around the world. And so in our infographic, we've talked about the red ring on the outside, what causes global change. In part 1, we talked about how the Earth system actually works. That's the yellow ring. And now we're focusing on the middle, the blue portion. The next few slides outline some of the measurable changes that occur in the atmosphere and hydrosphere. For example, we measure greenhouse gas levels and airborne particles in the atmosphere and sea level rise and ocean acidification in the hydrosphere. Notice that in how the Earth system works, the yellow ring, we talked about climate. But here we talk about phenomena we measure on an hourly and daily basis: temperature, precipitation, clouds, and wind, which we call weather. Some of these measurable changes in the atmosphere and hydrosphere will now be explained briefly. Explore the measurable changes in the Earth system page for more information about how these changes are connected to other processes and phenomena. Around the beginning of the Industrial Revolution in the 1750s, atmospheric carbon dioxide levels were at about 280 ppm, which stands for parts per million. And for the previous 800,000 years, were not above 300 ppm. However, the levels have increased to over 400 ppm due to human activities like the burning of fossil fuels, agricultural activities, cement production, and deforestation. Humans evolved around 300,000 years ago. So that's going to be all the way over here on our x-axis. So our species have never before lived in a world with carbon dioxide levels as high as they are today. The increase in greenhouse gases in our atmosphere due to human activities has increased Earth's average temperature as seen here. This map compares global surface temperatures in 2017 to the 1981-2010 average temperatures. The red parts of the map indicate the largest changes in temperature happened at high latitudes in the northern hemisphere, and that most of the planet is warming. Note that because heat is redistributed by atmospheric and ocean circulation patterns, slight cooling is observed in some regions, and that's clearly where the bluer areas on the map are found. Scientists track how much sea ice has melted using satellites. As the world has warmed, sea ice has reduced dramatically, especially in the last 10 years, shown in the 2017 map here. The melting of sea ice and ice on land influence other global processes, such as ocean circulation and how much sunlight is reflected by Earth's surface, also known as albedo, which you should already know. And so here you can see that what we have now is here in white, and you can see the yellow line. That was where the ice extended between 1979 and 2000. Sea level rise due to water flowing into the ocean from melting land ice, and because of the overall warming of the world, which causes ocean water to expand, which is called thermal expansion. Around 40% of the global population lives in densely populated coastal regions, and many communities are already affected by rising sea levels. And so here you can see how thermal expansion and added water have added to and caused an increase in the global sea level. And think about that. Think about if you lived on the coast. Think about what's happening in Miami right now. In Florida, we've got all kinds of flooding. And what does that do to the communities that actually live there year round, not just there for vacation? As human activities have increased carbon dioxide levels in our atmosphere, so here we're looking at ocean acidification as a measurable change. The carbon dioxide levels are the red line on this graph. About a third of that carbon dioxide has been absorbed by the ocean, and that's the green area that is below. And that ocean PCO2 means the partial pressure of CO2, like the amount of pressure inside of the water that carbon dioxide provides. As this carbon dioxide dissolved into the ocean, the acidity of the ocean has increased, which means that the pH has decreased, and that's the blue line. So remember that as acidity goes up, the measure of acidity, which we call pH, goes down. So a pH of 1 is more acidic than a pH of 6. Changes in acidity can stress marine organisms, especially those that grow calcium carbonate shells or skeletons, making it more difficult for them to grow and survive. Ocean acidification impacts species populations and food webs, including organisms that are food sources for humans around the world. And this was something that we talked about in one of our earlier activities, that as ocean acidification becomes more prevalent, those marine animals are not able to produce shells because their shells are dissolved by the acid, and therefore they die, and that takes away a major food source for all kinds of people who live in coastal regions. In this diagram, we have now added icons representing measurable changes in the biosphere and geosphere. In the next 2 slides, we'll briefly explain some of these changes. Okay. Human activities, especially land use practices and hunting and fishing, have dramatically impacted species populations, the number of individuals in a population, and species ranges, the geographic range over which a species is found. For example, wolves were once found in North America from the Arctic to Mexico, and after the 1920s, wolves were no longer found in most of the lower 48 states due to habitat fragmentation and hunting, as the species species was viewed as a threat to humans and livestock. In 1973, wolves became protected under the Endangered Species Act, and since then, populations have stabilized. Species populations and ranges are influenced by interactions with other species. For example, the reintroduction of wolves to Yellowstone National Park has decreased elk populations, which were overgrazing the vegetation. Since the reintroduction of the wolves, this vegetation has recovered because the wolves are eating the elk, which were eating all the grass. And that's going to provide food and habitat for other species, such as bison and beavers, which have become more abundant in the park. And if you feel like it, ask me about the wolf tracking class that I took in northern Wisconsin a number of years back. The effects of climate change can be measured by tracking shifts in the annual life cycles of plants and animals. These shifts include changes in the timing of growth and reproduction. For example, the date of the first blooms of flowering plants is often triggered by increasing temperatures with the onset of spring. As the Earth's average temperature increases, many regions become warmer earlier in the year, causing plants to bloom days to weeks earlier than they used to. See the orange and red dots on the map below, or on the map that we have here. So the orange and red dots are showing the greatest change in the first bloom date. This can be problematic for plant species if their pollinators do not also arrive earlier. Note that because heat is redistributed by atmospheric circulation patterns, which change with global warming, some parts of the United States may actually experience a delayed onset of spring, causing later blooming times. See the blue maps on the map. The blue dots, on the map. And these changes can be an issue for farmers trying to determine when to plant their crops or what species to grow. And the other thing that I want to mention about this is that probably about 10 or 12 years ago, the white pine trees in the Rocky Mountains started to die. And so scientists started to really look into why this was happening. And what they found is that there was a beetle that normally that was there, but that normally was in such low numbers that it would only kill a couple of trees. But because our average global temperatures went up, their reproductive time also extended. And so they just exploded. Their population exploded and decimated hundreds of thousands of acres of these white pine trees. Then, squirrels and bears and other animals use those pine nuts for nutrition. And so it really did have a spiraling effect among many different parts of the food web. As humans, we affect and are affected by the Earth system in many ways. The quality of human life is inextricably tied to the condition of our planet. In the center of the measurable changes section of the diagram are changes that most directly affect our health and well-being, including the quality and availability of fresh water and food. Poor environmental conditions can cause displacement of human populations. Here we'll briefly explore changes that affect the quality of human life. The quality of human life is dependent on the availability of clean, fresh water for drinking, sanitation, and agriculture. Our water reserves come from groundwater, lakes, and rivers, which are replenished through rainfall and snowmelt. Unfortunately, to meet the needs of growing populations, these reserves are being used faster than they are replenished, which causes water stress. See this map. Climate change exacerbates water stress by increasing the frequency and duration of droughts. And also as we need more and more lithium in order to create batteries for phones and batteries for electric vehicles, we are starting to take away water from the ocean, and then that in turn is going to cause greater flow of this groundwater into the ocean. And so we're kind of upsetting the balance of the water table by mining certain minerals, because the mining process requires a lot of water. We have caused many changes to global ecosystems and climate at unprecedented scales and rates. We must consider how to use the earth to maintain the resources necessary for the health of future generations. Through an understanding of how the earth system works, we have the power to make decisions, see a message of hope that can maintain and improve ecosystems, human health, and well-being across the globe. We have now completed our overview of the Understanding Global Change Framework, which provides a way to organize the many processes and phenomena that shape global climate and ecosystems. That's it, chemistry students. Please fill out your sheet, and I will see you in class. Thanks for listening. Goodbye.